Astronomers just found a planet that breaks almost every rule we thought we understood about where life can exist. It's rocky, it orbits a star almost identical to our sun. It completes one full year in almost exactly the same time Earth does. And it sits right on the edge of the zone where liquid water is theoretically possible. But here's what nobody is talking about. We don't actually know if this planet is alive with possibility, or a frozen, lifeless rock drifting silently through the dark. And that uncertainty, that's not a flaw in the story. That uncertainty is the story. The planet is called HD 137010b. And what scientists have found, and what they haven't been able to confirm, might be the most important astronomical discovery you've never heard of. Let's set the scene. 146 to 150 light years away from where you're sitting right now, there is a star. It looks almost exactly like our sun. Same temperature, same size. Same class of star. If you could stand in that solar system and look up at it, it would feel familiar, almost like home. And orbiting that star at a distance that takes roughly 365 days to complete one full loop is a world. It's bigger than Earth. Not enormously bigger, just slightly. Scientists classify it as a super-Earth, dense enough, heavy enough, and compact enough that all current evidence points to one conclusion. It is a rocky planet. Oh, not a gas giant swallowing everything in its path. Not a floating ball of hydrogen. A solid world with a surface. For decades, finding something like this was the dream. A rocky planet orbiting a sun-like star at a distance where temperatures could theoretically support liquid water. That's the trifecta. That's the holy grail of planet hunting. HD 137010b checks every single one of those boxes. So why aren't scientists celebrating? Because this planet sits on the outer edge of what scientists call the habitable zone. You've probably heard the phrase Goldilocks zone. Not too hot, not too cold, just right. Well, HD 137010b doesn't sit comfortably in the middle of that zone. It lives near the boundary, the cold side of the boundary. Here's what that actually means in numbers. This planet receives less than 1/3 of the sunlight Earth receives. Less than 1/3. To put that in perspective, Mars, the planet we consider our best candidate for past life in our own solar system, receives about 43% of Earth's sunlight. HD 137010b gets even less than that. Current models estimate surface temperatures could plunge to around -90 degrees Fahrenheit. That's not chilly. That's not bring a jacket. That is colder than the most extreme winters ever recorded anywhere on Earth. Colder than the surface of Antarctica at its worst. Potentially colder than Mars. If you landed on HD 137010b under those conditions, you would be standing on a frozen desert. Silent, still, no liquid water, no atmosphere thick enough to breathe, just ice, rock, and an unforgiving sky. That's one possibility, but here's where the story refuses to be simple. Earth should not be as warm as it is. If you strip away our atmosphere and calculate the temperature purely based on how much sunlight we receive, Earth would be a frozen world. Yeah, its average temperatures would hover around 0 degrees Fahrenheit. The oceans would be solid ice. Life as we know it would not exist. What saves us is our atmosphere. Carbon dioxide, water vapor, methane, these gases trap heat like a blanket wrapped around the planet. We call it the greenhouse effect. And it raises Earth's average temperature by roughly 60 degrees Fahrenheit. Now apply that same logic to HD 137010b. If that planet has a thick atmosphere, rich in carbon dioxide, you're rich in greenhouse gases. Everything changes. The math changes. The temperature changes. A world that should be frozen becomes a world where liquid water is possible. Maybe probable. Scientists estimate that with the right atmospheric composition, HD 137010b could transform from a frozen wasteland into something far more interesting. An icy world with liquid oceans beneath the surface. A planet where temperatures climb high enough to sustain complex chemistry. Maybe even the conditions where life, in some form, could take hold. The problem is we don't know what its atmosphere looks like. We can't measure it yet. The technology isn't there. So right now, that question hangs open like an unfinished sentence. And it gets even more complicated because HD 137010b isn't even officially confirmed as a planet yet. Here's how planet hunting works. Telescopes, like NASA's Kepler Space Telescope, monitor thousands of stars simultaneously. watching for a very specific event. A tiny, almost imperceptible dimming of starlight. That dimming happens when a planet passes in front of its star, what astronomers call a transit. It's the planet's shadow briefly blocking a fraction of the star's light. It sounds simple, but confirming that what you've detected is actually a planet and not a random fluctuation, not a background star, not an instrument glitch, requires seeing that transit happen multiple times, yet it's in a precise and predictable pattern. HD 137010b has been observed transiting its star exactly one time. During NASA's Kepler K2 mission, scientists caught one dimming event consistent with a planet of this size and orbital period. One observation is a candidate, not a confirmation. To be officially classified as a planet, scientists need to see it transit again and again. They need repeated, consistent data before they can say with certainty, yes, this is real. Future missions, particularly NASA's TESS telescope, the Transiting Exoplanet Survey Satellite, may be able to provide those additional observations. But until that data arrives, HD 137010b remains technically in limbo, a candidate world, a possibility, a question mark floating 147 light years away. Computer models have run the numbers, and the results are striking. There is roughly a 40 to 51% probability that HD 137010b falls within the habitable zone, the region where liquid water can exist on the surface under the right conditions. Think about what that means. Scientists, with all of our telescopes and mathematical models and decades of research, are essentially saying there is a coin flip chance this planet could support life. Heads, it's a frozen, barren desert with temperatures so extreme that nothing as we understand it could survive. Tails, it's a world with liquid water, a thick protective atmosphere, and conditions that could theoretically harbor life. A 50-50 shot on a planet 146 light years away that we've only seen once. That is where we are in the story of human space exploration right now. And if that doesn't give you chills, I don't know what will. HD 137010b doesn't exist in isolation. It enters a growing list of worlds that scientists are watching closely. Take Gliese 667 cc, a super-Earth just 22 light years from here, close by cosmic standards. It orbits its star every 28 days and may sit within the habitable zone. But there's a catch. It orbits a red dwarf star, a type known to unleash violent stellar flares. The same star that keeps it warm could also be constantly bombarding it with radiation, powerful enough to strip away any atmosphere. Then there's Kepler 22b, about 600 light years away, orbiting a sun-like star every 290 days. It sits beautifully within the habitable zone. But scientists still don't know if it's rocky, gaseous, or something in between. Its composition remains a mystery. And Kepler 69c sits 2,700 light years away, positioned in its solar system similarly to how Venus sits in ours. That comparison is worth pausing on, because Venus is a warning. Venus is almost the same size as Earth. It orbits a similar star, and yet it has become one of the most hostile environments in our solar system. Surface temperatures of 900 degrees Fahrenheit, atmospheric pressure 90 times greater than Earth's, clouds of sulfuric acid, a runaway greenhouse effect so extreme it turned what might once have been an ocean world into a literal hell. If HD 137010b has too thick an atmosphere, it doesn't become Earth, it becomes Venus. And then there's TOI 733b, discovered just in 2023. Possibly an ocean world, potentially covered entirely in liquid water. Another candidate, another question mark. Every single one of these planets teaches us the same lesson. Finding an Earth-like world is not the end of the search. It's the beginning of a much harder question. Here is what we know for certain. In the last 30 years, we have gone from knowing about 0 planets outside our solar system to cataloging over 5,500 confirmed exoplanets, with thousands more candidates waiting for confirmation. We went from theory to proof, from speculation to observation. And with every new discovery, the picture gets more complex and more extraordinary. HD 137010b isn't a backup Earth. Nobody is booking one-way tickets. Nobody is packing their bags, but it checks boxes that almost no other planet has checked simultaneously. Rocky composition, sun-like star, Earth-like orbital period, and a position in or near the habitable zone. It is a target, a serious, legitimate, scientifically compelling target for future observation. When TESS gathers more data, when the James Webb Space Telescope turns its instruments toward worlds like this and begins analyzing their atmospheres, we will start getting answers that right now we simply cannot access. And one of those answers on one of these planets on some future observation might change everything. Not the discovery of a signal, not a radio wave, not a message, just the quiet, breathtaking confirmation that liquid water exists on another world. So that the conditions for life are not unique to this small blue dot. That discovery would be the most significant moment in the history of human civilization. And HD 137010b might be one step in that direction. We are living in the golden age of exoplanet discovery. The telescopes are getting sharper, the models are getting smarter, and the universe is slowly revealing itself. One transit, one dimming of starlight, one data point at a time. Hence, HD 137010b is a reminder that the cosmos doesn't hand us certainty, it hands us evidence. And we have to be patient enough and curious enough to keep asking the questions. If this kind of deep dive into the science of space exploration is what you're here for, hit subscribe. Every day we go further, dig deeper, and explore the discoveries that are quietly reshaping what we understand about the universe and our place in it. And drop a comment below. Do you think HD 137010b is a frozen wasteland or a hidden ocean world? I want to know where you land on the coin toss. The universe is waiting. Let's keep looking.